All right, welcome everybody. So in this video, we are going to continue working with the storms data set from the dplyr package and thinking about how we can create plots for some of the variables in that storms data frame. In this case, we're going to create a plot for a quantitative variable. In the previous video, we created a histogram for the wind speeds. In this video, we'll create a different plot for wind speeds. We'll create a box plot, and box plots, if you recall, is a visual representation for a 5-number summary. So I assume that you've taken a previous statistics course and you're familiar with 5-number summary. I'll give you a quick rundown of the 5-number summary in case it's been a little bit, but if it has been a little while since you've worked with 5-number summaries or box plots, I would definitely encourage you to reach out for help. Don't hesitate to contact me. The point of this video is how we can create them in R, not necessarily what is a 5-number summary or how we read box plots, since again, I assume you've seen those in a previous course. That might not be a fair assumption. So if that is not the case for you, please don't be shy. Just let me know if you need a hand refreshing those concepts from statistics. But a 5-number summary, as the name implies, consists of 5 numbers: the minimum value, the first quartile, the median value, the third quartile, and the maximum value. And so what's nice about a 5-number summary is we've got these 5 numbers, and it splits a data set up so that 1/4 of the values fall between any pair of consecutive values in a 5-number summary. So 25% of the values fall between the minimum value and the first quartile, 25% fall between the first quartile and the median, 25% between the median and the third quartile, and then the last 25% fall between the third quartile and the maximum value. And so what I mean between 25% is that 1/4 of the values fall in between any one of those pairs of values. And so the first quartile, by definition, this is the 25th percentile of the data. So that means 25% of the values in the data set are less than the first quartile. The third quartile is the 75th percentile of the data. 75% of the data is less than the third quartile. The median is the midpoint of the data, meaning 50% of the values are less than the median, 50% of the values are greater than the median. So in R, we've got various functions that we can use to calculate each of the individual values in the 5-number summary. We can use the minimum function to calculate the minimum value of a data set. We can use the quantile function to calculate any quantile value. In this case, we are looking for the first quartile and the third quartile. So those in particular correspond to the 25th percentile and the 75th percentile, which are the 0.25 quantile. So for those that are just starting this notebook, by the way, we're working with the storms data set, which is from the dplyr package. So if you want these code cells to run that I'm running right now, you're going to want to go and run all of the previous code cells in this notebook. So you're going to want to go to runtime, run all of the code cells before this one. It's going to open up some help documentation because there are some help commands in the prior code cells. You can close all of those out, and now you're up to speed. So again, this quantile command here is saying, go into the storms data frame, look at the wind variable, and find the 25th percentile of the wind speeds. Median is finding the median wind speed. This is finding the 75th percentile. this is telling me what is the maximum wind speed. And this is the 5-number summary that I get down here. We can get all 5 of those values in one single command using the 5num function. And the summary command that we've used in the past gives us a 5-number summary. Just be careful that it throws the mean inside of here as well. The mean is not part of the 5-number summary. So the 5-number summary would be the minimum value, the first quartile, the median, the third quartile, and then the maximum. So in this case, the 5-number summary would be 10, 30, 45, 65, 165. So 1/4 of the observations in our storms data set have a wind speed between 10 knots and 30 knots. Another 1/4 of the observations have a wind speed between 30 knots and 45 knots, and so on. That's how we can read the 5-number summary. So that's a quick crash course in 5-number summaries. Box plot is a visual representation of the 5-number summary. I'll skip kind of the details of creating these box plots in general. If you've got some questions, you can kind of read the details up above. But how we would create a box plot in R is not with the plot function. By default, the plot function, if I do plot quantitative variable, remember it's going to create an index plot. Wind is a quantitative variable, so this is going to create an index plot, and that's not useful here. That's not what I want. Box plot creates a box plot of the wind speeds over here. So this is just like a really basic plot without adding any additional options. In this code cell down here, I've added some options to maybe clean it up a little bit. So I added some labels. Over here, I added a feature, an option called horizontal equals true to make my box plot go horizontally, since the default is to make the box plot go vertically. This is really a cosmetic thing. It does not matter whether your box plot goes vertically or horizontally. And these other options are giving me labels, a main label, a label to the x-axis. Over here, I've actually turned off the tick marks on the x-axis. So I don't see any values over here, which is not good, right? I would like to know what the values are. I just turned them off. And this is changing the font sizes for some of these labels. So let me turn the tick marks back on. And here I've turned them back on. And the point here is that maybe these are not the best tick marks to include. And I'll just say, like, our box plot over here has a bunch of dots at the end. And if you recall from box plots, each of these dots in the box plot corresponds to what we call outliers. So all of these storms over here correspond to outliers. These are storms that had really, really high wind speeds. But I want to add my own tick marks to the axis down here. I want to add tick marks at exactly where the 5-number summary is. So I want to add a tick mark at 10, 30, 45, 65, and 165. So I want to add 5 tick marks, one at each value corresponding to the 5-number summary. So I want to add a tick mark at each of these vertical lines that it corresponds to the box plot. So that's why I turned it off. So one thing that we can do is we can customize our axis. So let me run this code cell over here. So what this does is this command over here turned off the default tick marks, because the default tick marks were at 50, 100, and 150. None of those values happen to correspond to any value in my 5-number summary. And then I could customize where I add my tick marks by adding an axis command. And so this axis 1 means 1 corresponds to the horizontal axis, the x-axis, as opposed to the vertical axis. So just to kind of see what happens if I set the axis to 2, it would add them, I believe, like over here on the vertical axis. If I set the axis to 3, it adds them up top. And if I set the axis to 4, it would be on the right side. So, which has no value, so it's not appearing. So there are 4 axes on this plot. There's a bottom, a left, a top, and a right. Axis 1 corresponds to the bottom axis, which is where I want to add my customized tick marks. So the first value here says, well, which axis do you want to add tick marks to? I want to add it to the bottom axis, which is axis 1. And then the next thing is, well, at what values do you want to add the tick marks to? And I could either enter a vector of values. So for example, I could say ten, 30, 45, 65, 165. So I could define my own vector of values like this and run this code cell, and it added 1, 2, 3, 4, 5 tick marks at where I specifically said. But what's nice is by doing it in this way, I didn't have to type them in myself. So sometimes if you want to add like a whole bunch of tick marks, you could do that using a function. So in this case, I wanted to add tick marks at each of the 5 numbers, so I could do that. If I wanted to add tick marks at a pattern, we've talked earlier in this module about how to create a pattern vector. I could say, hey, start at 0, go up to 170, and increase, or maybe I could say go up to 200 and increase by 25. And now I've got, a nice pattern vector of tick marks over there. So you can customize your tick marks by creating pattern vectors like that. For a box plot, maybe my goal here is to just add a tick mark to make it clear what the 5-number summary is here. And notice another thing that I did is I added a title to the overall plot. And this is just the same exact thing as if I added a title using the main option in the box plot. So there are different ways that I can add a title to the box plot. I can either do it as an option inside of the box plot function, or I can do it using the title function outside of the box plot command itself. So here's a nice box plot. I can change the color, the fill color of this. So if you run question mark box plot, you can see there are lots of other options that you can do to tweak that box plot. Okay, in the next video, we'll talk about how you could create some plots if you want to compare not just to plot one individual variable, but if you want to compare multiple variables in a single plot. So for example, to create side-by-side box plots in one single plot.